tell if something is linear or not, what you do is you find the rate of change or the slope between all the consecutive points. And if their rate of change is the same, then it's linear. If the rate of change for all of them is not the same, it's not linear. So to do our changes in y's first, 1 to 1.4 is a change of 0.4. From 1.4 to 3.8, it's 2.4. Now, if you don't know that, you do a subtraction. You take the second value, subtract the first value, that gives you the change. And then 515 from 380 is 1.35. Now, while those are different, that doesn't tell us we're not linear. We need to check if the change in y divided by their change in x's are different or not. So now for the years, first we're going up 11 years, then we're going up 23 years, and then we're going up 10 years. So now that we have the changes, we can see if that ratio, the change in y over change in x's, are the same or different. So first we had 0.4 over 11, 0.4 over 11. We want to know, is that the same as 2.4 over 23? Is that the same as 1.35 over 10? So simply put, you can type those in your calculator, and we get 0.36 is equal to 0.104. Now we can stop right there and say it's not linear. We don't even need to check this, because if any of the slopes are not the same, then the whole thing is not linear. So this here is your work to show, and you would say, no, not linear. So for number 19, we're going to do the same thing we did for 18, but we need to read the situation and figure out the table so we can actually do our change in y and change in x. So here it says that for her next practices, she's going to add her previous 2 practice minutes together, and that's going to be her next days minutes. So I made a table, days and minutes. So first day, she said 1 minute. Second day, 2 minutes. And so now for all the next days, 3, 4, 5, that should be enough. We're just going to add the previous 2 together. So 1 plus 2 is 3. And then 2 plus 3 is 5. Then 3 plus 5 is 8. So we're just adding the previous 2 days minutes to create the next day. So in this case, notice how the days go up by 1 every time. So now if the days go up by the same amount, then the minutes must also go up by the same amount in order to be linear. So here at first it goes up by 1, then 1 again, but then it goes up by 2, and then it goes up by 3. So 3 divided by 1, 2 divided by 1, 1 divided by 1, those are not all the same. So no, not linear. And the last problem here is number 20. Same deal, we'll make a table. Here we're talking about weeks and the amount of money Albert has. So at week 0, he has $10. Week 1, he has 15. Week 2, he has 20. Week 3, he has 25. Having 4 points should be enough to show and make your decision. So kind of like the previous problem, the weeks are going up by 1 every time. Now we need to look at the y values. So up 5, up 5, up 5. So in this case, the rate of change is 5 over 1 from 1 point, then 5 over 1 to the next, 5 over 1 again. Those are all equal. Yes, those are equal. So yes, it is linear.